Hi everyone. I'm recording this video to show you the solutions to homework 5. So for the homework 5, the first hash table. So for this hash table, what I'm expecting you to do is, well, we want to introduce some randomness into a hash table. So we created a collection of 3 hash functions. So I want to do a list of the methods like this. And then every time we create a hash table, there could be a random seed generated, and the random seed should be an integer value from 0 to 3. Okay, so in this case, every time we create a hash table object, and then we have a random seed, and this random seed tells me, well, in this lifetime of the hash table, which is the hash function I'm going to use. So if this random seed gives me a 0, and then this means in this hash table I'm going to use the existing hash function. And if it is 1, I'm going to use a multiplication, and if it's 2, it's a universal hashing. Okay, and then, well, this is the first part I'm expecting you to implement. And the second part is we have to guarantee the consistency. And this means, well, if we have such a hash table, and then when we are putting a new key value pair into the hash table, we want to guarantee that we want to take a look on the random seed and then use this random seed to grab a corresponding hash function to use from this array. So this is how I did it. So, well, if I'm doing a put, and then I want to go and grab my hash functions and then use my random seed as a key. So if the random seed is a 0, and then I'm gonna grab the first hash function from my collection of hash functions. And then I'm going to send in, well, the key and then the current length as the 2 parameters. So those 2 parameters will send to one of those methods, and then eventually I can grab the hash value to do my put. And similarly, if I'm trying to do a get, it will be the same thing. So I'm going to use the random seed to grab the hash function that I should use for this hash table, and then I'm going to send in the key and then the length, so I'm going to find the slot. Okay, so there's going to be a consistency here. Okay, and the next question. So for the next question, we are using a min heap. So for this min heap, you don't have to do anything, but, well, we want to make use of a min heap to create a fixed size version of the min heap. So, well, let's take a look on the min heap first. So for example, if we, well, for a min heap, the smaller value always is on the top, right? So, well, we are going to have a 0. So this 0, you can consider this as a hidden value on the first slot of this array. So we don't use that, but we just put a 0 here as a placeholder. Okay, so if we have a 5, so okay, so 5 is smallest value. And then how about 6? If we add a 6 to this heap, is this still a min heap? The answer is yes. So how about we have a 3? So by default, we are gonna put the 3 here, right? Well, but if we put the 3 here and this is at the wrong location, so what do we do? So we want to do a swap. So we want to swap the 3 up, and then we want to put this 5 down. So in this case, it is still a min heap. And then how about 4? So we are going to put 4 at the next open slot. So 4 is here. So is this the right location for 4? The answer is no. So we want to swap the 4 and 6. So we are going to have to put the 4 here and then the 6 here. And then, well, this is the new location for the value 4, but is this the right value? We have to check again. And it turns out that, well, the parent of 4, which is 3, is smaller than 4, so that is the right location for 4. So the next value, we have 7. So once we put the 7 here, well, we don't break the property of the min heap, so that's good. And then we have the 8. Well, in this case, well, if we just have an ordinary min heap, well, it is what it is. So I'm going to have an 8. Well, it doesn't break any of the min heap property. But in my problem, what I want to do is I want to do a fixed length min heap. So when this 8 coming in, well, we know, well, our target length of the min heap is 5, and then there are already 5 values. So in this case, how do we add the 8? So we have to check one thing. So let me erase this part. So we are saying this 8 is coming in, and this min heap has already got 5 values. Okay, so do we want to take this 8 into the min heap? Well, the answer is yes, because 8 is a higher value than the minimum. So what can we do? So my process is, well, I want to first drop the minimum from the min heap. So I want to drop this 7. So once this 7 is dropped, and then, well, who is going to take the location of the 7? The answer is the last value on the min heap. So we are going to write down a 7 here. Okay, so now we drop the smallest value from the min heap, and after that we only have 4 values. Well, do we want to put the 8 in right now? The answer is no, because once we drop the smallest value, this min heap is no longer valid. So how do we fix that? Well, the min heap implementation will do that. So you see, once we are deleting the min, and then we are going to do a heapify on this value, because this 7 is not at the right location. So this delete min will do this for us. And then, well, what's the process? The process is we want to swap the 7 with the smallest children. So, well, 4 and 5, we are going to swap with the 4. So 4 will be here, 7 will be here. So is this 7 at the right location? And the answer is no. So we want to swap this 7 down again. So 7 and 6, they are going to swap again. We are going to put the 6 here, and we are going to put the 7 here. Okay, so in this case, we have a valid min heap of 4 values. So once this delete min is done, well, we can do one more thing. That is, we want to do a insert. So we have the 8 in. So this insert is already in the min heap. You don't have to write the code for that. And, well, we want to put the 8 here. So once we put the 8 here, well, if it is necessary, and we may have to fix up this 8 again, but luckily we don't have to do so. So this is how we handle the incoming 8. So the next point, we want to handle the incoming 18. So the process will be similar. So when the incoming 18 here, and we find, okay, this 18 is greater than the current smallest value, so we want to get rid of this 4 first. So we get rid of this 4, and then we want to swap with the last value in the array. So we are going to put the 8 here, and we find this breaks the property of the min heap. So we want to fix the min heap. So, well, 8 is going to get swapped with the smallest children, that is 5. So 8 swap with 5. So this heap is fixed, right? So once we have this fixed, and then we are going to put the 18 here, and then this will be the new location for the 18. And then once we have inserted the 18, and then we can say, okay, if you send a tip higher than 5, and then you will receive a Raspberry Pi. Well, how do I get this 5? This 5 is the smallest value in the min heap, and then this, where is my my minimum? So the minimum is going to be the pick. So you pick as a min heap, and then you get this 5, and then you say, okay, the current smallest value is 5. Okay, so, well, this is my implementation. So, well, this implementation is, we want to start from a implementation of a min heap, and then we want to update it to be a version that has a maximum numbers of the min heap. So in the constructor, I have the min heap, and then I also have a fixed size. So this is the maximum of the size I can have. So when there is a new value incoming, I want to check if this min heap is already full. So if this min heap is already full, and then I have to delete a value, and then we have to fix it again. Well, if this min heap is not full yet, and that's easier, well, we just insert the value, right? And then how about the pick? So if I want to pick and to find the highest value, and then I just grab the heap, and then I want to do a pick. And then, well, if I want to do the ins highest tape amount, and then I do a pick again. So this is the implementation I have done. Okay, so this is one of the solution, and this is not the only solution possible. And the challenge for this part is, well, you start from a implementation of a data structure, and then you want to make use of this data structure to implement something you want to do. Okay, so this is my solution for the homework 5, and then I hope you have a good weekend. Bye bye.